Hello, Integrated Math 1. Welcome to lesson 1.3.1, where we're going to start talking about linear regression, specifically using the least squares regression. But before we get into that, linear, we're talking about lines. We were graphing lines last time. We're going to be doing some more graphing with lines this time around. So just to kind of jog our memory a little bit, we have a lovely little warm-up here for you. We're just doing the one warm-up, and you're going to use the slope formula to write an equation for each. So remember our whole little, let me grab my little pen here. So remember your whole little y equals mx plus b. Yeah. Some of these things you have, some of these things you don't have. So see if you can play with it a little bit and find the equation for this. Go ahead and hit pause. Try to work this out as best you can, and then hit play when you're ready to check your work. So I know one of these things, right? I know my slope is 5. I'm like, great. So I know, sorry, there's a little fly in here. So I know that y equals 5x. The problem is I don't know b. I don't know my y-intercept. I know my slope, but I don't know my y-intercept. So here's what we're going to do. They gave us a point to work with, right? They gave us a point. There's my x-coordinate. There's my y-coordinate. So what I'm actually going to do is I'm going to find b. I'm going to find my y-intercept by plugging in a 2 for x and plugging in a 5 for y. And I can work this out. I can totally figure out what b is. 5 times 2 is, of course, 10. If I want to get my b all alone, I do need to subtract 10 from both sides. 5 minus 10 is, of course, negative 5. And, oh, great, I found b. I found my y-intercept. So it looks like my slope is 5. My y-intercept is negative 5. So y equals 5x minus 5. Yay! And we found our equation. Hooray for us. Good job, us. So let's keep this party going. Like I said, we're talking about something called least squares regressions. You're probably just going to refer to it as a linear regression or a best line of fit. We're going to talk about what that means as we go through this. So we do have several learning goals today. We're going to create a graph of data points, both with and without technology. I love my technology. You're going to determine a linear regression equation using technology. Yes, we're going to use technology for this. I'm not making you do that by hand because that gets crazy. And we're going to make predictions about our data using a linear regression equation. So there's a lot of key terms like least squares method, centroid, regression line, interpolation, extrapolation. I can say it. And we're going to talk about all of these today. So you have searched for patterns in graphs and sequences of numbers. How can you use what you know to identify patterns in sets of data? So yeah, we can find a pattern in our graphs pretty easily. And if our numbers are written in a numerical sequence all in order, then we can recognize patterns. But what if I just get a bunch of data? How can we recognize the patterns? So let's go over to page M1-164. We're going to talk about frozen yogurt. Mr. Templeton's Future Business Leaders Club, FBLC, is how we're going to abbreviate it, is helping a frozen yogurt shop located near the school analyze how the business is affected by the weather. It's frozen yogurt, people. It's going to be affected by the weather. The owner is wondering whether there's a relationship between the temperature and the number of customers that buy yogurt during the 2 hours immediately after school. And the FBLC collected this data. So you can see when it was 45 degrees outside, 45 degrees Fahrenheit, as I plunged into darkness, they had 97 customers. When it was 25 degrees Fahrenheit, they had 55 customers. 60 degrees Fahrenheit, we had 85 customers. 15 degrees Fahrenheit, only brought in 37 customers. It's a cold day. And 100 degrees Fahrenheit, that's a warm day, that brought in 100 customers into the shop. So what you're going to do is you're going to construct a scatter plot. That just means you're going to plot the points. Now, the next several pages walk you through plotting point, 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 each point. And if you have a piece of uncooked spaghetti, dry spaghetti, this is going to work best. If you don't, you can use just something like a pencil, something like that as we go through. Obviously, you're using a pencil anyway to write stuff. But we're going to see if we can try to approximate a line that models our data. So go ahead and go through parts A, B, C, D, all the way down until you've plotted all 5 points, and keep trying to draw a straight line through it. Again, it helps if you have like a dry spaghetti noodle that's just super straight and doesn't bend, right? To try and approximate a line that would model your data. So go ahead and hit pause to work your way through these, and then hit play when you're ready to keep the discussion going. Now, I plotted my first point. It's hard to make a line with only 1 point, right? So I'm going to go ahead and plot my second point. Now that I have a second point, I could easily draw a line that would model the data, couldn't I? But if I put in my third point, I can't do a line that's going to hit all 3. So I'm now having to approximate a little bit, aren't I? If I put in my fourth point and my fifth point, so here I have all 5 points on my graph, I can't draw a straight line that's going to hit every single one of those points, can I? But using your dry spaghetti noodle or whatever else it is that you have, you can go ahead and try to estimate a line. So I'm going to do that. I'm going to try and estimate a line. This is not going to be a very good line, and that's okay. We don't mind. That's fine. Hang on, helps if I make sure I'm on the right page. Now I'm on the right page. Hey. So I'm going to go ahead. This is not working for me. Sorry, guys. Technical glitches. That's not what I wanted. That's what I wanted. Awesome. So I'm going to come here and I'm going to draw a line that I think does a pretty good job of estimating my data. And again, it's not perfect because it's not going to hit every single line, and that's okay. Let me get my line up and running. All right, so I'm going to draw a line, and it's not going to be a perfect line, but I'm going to kind of estimate it kind of through here and kind of get it there. So this is not a perfect line, is it? You can see it doesn't hit every single point. You can see that the line I just drew is closer to some points than others, but I did kind of estimate roughly a line that's going to work for this. And I could even write an equation for this, right? We just wrote an equation earlier, right? Y equals mx plus b. Well, it looks like I made my my y-intercept at 40. So it looks like it hits my y-axis at 40. And again, your line may look a little different, which means your equation is going to look a little different than mine. That's okay. And I'm going to go ahead and estimate my slope as well. So if I go from here, and it looks like I did go through that point. So if I go 5, 10, 15, so I rose 15, and I went over 5, 10, 15, 20, 25. Looks like I went over 25. And to make it easier, I am going to simplify that just a little bit. So 15 over 25, I can divide both of those by 5. So it looks like I get about like 3/5. So it looks like I have an equation of y equals 3/5 x plus 40. Now, your equation may look different than mine. Your line might look different than mine, right? Maybe you did yours a little more slanted, or maybe you tried to get it to hit those 2 points. It's up to you. But this is the line that I have estimated. What you have approximated and I have approximated, we have approximated a line that best represents the data within each, with each additional point. And it's not perfect, right? So using the full data set and the line that you approximated to write an equation that you think best represents the data. And that's what we just did. So why don't here, you go ahead and write down the equation that you came up with for the line that you made. Again, it probably looks different than mine. So here's my line. So I'm just using this to estimate things. Yeah. Now that I've done that, remembering that X is my temperature, and I'm going to point that out. X is the temperature, and Y is our number of customers. So I'm just making some notes here. So, and again, your equation probably looks different than mine. That's okay. There's nothing wrong with that. Here's what I would like you to do. Use your equation to predict the number of customers to visit the frozen yogurt shop in the 2 hours after school for the given temperature. I'm just going to do A. If you want to do A, B, and C, that's totally fine. But use the equation you just made and plug in that 85, see what you get. Go ahead and hit pause to work this out. Hit play when you're ready to check your work. So I'm going to use my equation, y equals 3/5 x plus 40. And I'm going to go ahead and plug in that 85. So y equals 3/5 times 85 plus 40. And this is why I have my calculator handy. Yeah, bust out the calculator. So 3 times 85. Oh, it's too dark in here. That calculator doesn't want to work for me. I'm going to grab a different calculator. It's all good. So remember, when you multiply with fractions, you multiply with the top, you divide with the bottom. So I'm going to do 3 times 85. And then I'm going to divide that by 5, and I get 51. And then, of course, 51 plus 40, the lights have returned. I get 91. I guess I didn't really need a calculator for that last one. I could have done it. So based on my equation, I'm going to predict that 91 people will come into the shop to buy yogurt when it's 85 degrees outside, to buy frozen yogurt. If you have somebody else that's working with you, you might want to compare your predictions. And if you do, your predictions might be a little bit different, right? Like your prediction might be different than your partner's prediction. And that's just because they may have had a slightly different equation than you did, and that's okay. So you've noticed that estimating a line of best fit can give different predictions. Fortunately, with technology, you can create prediction equations as well as scatter plots from tables of data. You just need to build a data table that has an independent variable and a dependent variable. So real quick here on number 4, can you just identify the independent and dependent variables? Can you just do that real quick? Go ahead and hit pause, identify our independent and dependent variables from our table earlier, and then hit play to keep going. Now you guys know that independent is our X, independent is our input. So the temperature outside is the independent variable, and the number of customers is going to be our dependent variable. Now here's what I want you to do. I need you to go to desmos.com/calculator. That's going to bring up a graphing calculator. Now I'm going to go there as well in just a minute to show you how this is done. And you're going to generate a line of best fit. And we're going to find the slope and the y-intercept of the line and all this good stuff. Before I go over, though, I want to show you the process. So the first thing you're going to do when you get to Desmos is you're going to make a table. Okay? So if you come over here to desmos.com/calculator, hang on, I'm going to pop that up there. I'm going to make a table. So I'm going to hit plus. And look, when I hit plus, it says table, and I'm going to put a table there. So you're going to fill in the table from before. So you're going to start with that, okay? Once you have filled in your table, what you're going to do next is you're going to fill in the table with points from your data set. On the next line, you're going to type in this equation. Y sub 1 is approximately m times x sub 1 plus b. And what this will do is it will give you your slope and y-intercept and allow you to write your new equation. All right? So let's come back over to Desmos. And let's go ahead and let's put in our data from our table earlier, right? We need our data from our table. So I'm going to look in my book here. I'm going to look in my lovely book. Over to my table. course, I have to get to the right page. There it is. And I'm just going to start typing in. So we said when it was 45 degrees, there were 97 people buying yogurt. And then we said when it's 25 degrees, there were 55 people buying in the shop about 2 hours after school. When it's 60 degrees, there were 85 people in there. When it was 15 degrees, so cold, there were still 37 people in there buying frozen yogurt. Apparently some people just always eat frozen yogurt. And it was 100 degrees, we had 100 people buying frozen yogurt. So we've done step one. We've made our table. Now, I don't see the dots here. So here's what I'm going to do. I'm going to zoom out because you can see I've got some big numbers here, which I can't see on my graph because it only goes up to 10. So I'm going to zoom out a bit here. There we go. Now I can see some of these dots. There we go. That's great. And I'm going to scooch it over a little bit so I can see my graph a little better. I'm going to kind of scooch, scooch, scooch. There we go. And now I can see all 5 of my points. We made that earlier, but now we've made it on our graph. Hooray! Now, Desmos can make the line of best fit. Do you remember how we did that? I'm just going to bring this up real quick. Remember that we're going to write this equation. Y sub 1 is approximately m times x sub 1 plus b. Remember, we said that's the next thing we're going to do. So down below, where I'm going to click here, where there's space for me to write the equation. The cool thing about Desmos is if you just type y1, it automatically does a little sub for you. Isn't that nice? Now, please notice we're not putting an equal sign this time. We're putting a little tilde. It's next to the one on my keyboard. It might be in a different spot on your keyboard. And of course, I'm also going to point out, go away. I'm also going to point out, this is in the way. Go away. There is a little keyboard here on Desmos that'll give you all kinds of stuff, all kinds of stuff, all kinds of stuff, okay? So if you need to use the keyboard, you are welcome to do so. I'm going to come back. Hi. But if you just type Y1, it'll do it. And then I'm going to hit the little tilde because I don't want to do equals. And then I'm going to type M. And again, I want X sub 1. So if I just type X1, the computer will automatically do that for me, which is so nice of them. And then we'll put plus B. Check out what just happened. They just made a line of best fit for us, didn't they? And if you look, look, what do you see? Do you see M for your slope? You have your slope. Shut the front door. And do you see B equals here? Check it out. You've also got your y-intercept. You have both your slope and your y-intercept right here. We can write the equation. Now, to make this a little more manageable, because there's some decimal craziness going on, I'm going to go ahead and round to 3 digits behind the decimal just to make it a little more manageable for me. So I'm going to say that my slope is 0.687 because that's a 5, so I have to go up. And then I'm going to say my y-intercept is 41.15, and we'll say 8 because that's a 7, so I have to go up. And you can now write your equation. So go ahead and use these to write your equation on number 5 on page 166 in your workbook there. I'll give you a moment, hit pause, write down your equation, and then hit play to keep going. So I wrote down my new equation. There's my slope that I took from Desmos. There is my y-intercept that I took from Desmos. It did say to explain what they represent. Well, this means, this is my y-intercept, right? This is where it hits my y-axis. So that means if the temperature is 0 degrees outside, it is cold. The temperature is 0 degrees outside, I should still get about 41 people coming into the shop, right? This is my slope. So this means for every degree I go up in temperature, I'm going to get 0.687 more customers. We do usually round our customers to the nearest whole number, though, because you either have a customer or you don't have a customer. You don't usually have people walking in your door, because that's creepy. So now use your new line. In fact, I'm going to put it up here. Use your new line that we just made. Can you use the new line of best fit and go ahead, plug in that 85 and predict the number of customers at the frozen yogurt shop immediately after school for this given temperature. Go ahead and hit pause to work this out. Hit play when you're ready to check your work. So I went ahead and plugged in an 85 for X. I used my calculator to multiply these. I have my lovely calculator here that I'm using to multiply. And I got 58.395. And then I went ahead and added to this one right here. Again, we are going to round to just 99 because I don't want 0.5 of a person walking through my door. That's creepy and scary and just disturbing. So at 85 degrees, the yogurt shop should expect approximately 99 customers. About that. It's about what we should be expecting. So the equation that your calculator uses gives you the line of best fit is called the least squares method. Our Desmos calculator is actually using a very specific method to calculate the line. So this is a method that creates a line of best fit for a scatter plot, and it has two basic requirements. You don't have to memorize these, but it's good for you to at least know what they are. The first requirement is that the line must contain the centroid of the data set. I need a point, right? The centroid isn't any old point. The centroid is a point whose x value is the mean of all the x values on the scatter plot, and the y value is the mean of all the y values on the scatter plot. They're literally finding the average point. Find the average of your x coordinates, find the average of your y coordinates. That's your centroid. The other thing that they're doing is they're finding the regression line because, of course, an infinite number of lines can pass through that point, right? So even though infinitely many lines can pass through the centroid, the regression line, which is what we found, has the smallest possible vertical distances from each given data point to the regression line. The sum of the squares of those distances are at a minimum with this line. So again, you don't need to memorize this, but this is just what we know. So it has a centroid, right? So it's like, okay, here's the average point. Here's the average x coordinate. Here's the average y coordinate. And then it finds the least distance, vertical distance. So here's our point, vertical distance, vertical distance, vertical distance. It has all these guys. And it does squares of all of them, and that's the minimum. Again, you don't have to calculate this out. Desmos is doing all of this for you, but it's just so you know there is a method to your calculator's madness. So we're going to skip all the way over to page 171. And what I'd like you to do is I have a new table for you. I have a new data set for you. The music industry is constantly changing how it delivers music to its listeners. The table shows the percent of total US music sales revenue from streaming. And that's how most of us are getting our music these days, right? It's totally shifted in the last 20 years. Oh my gosh. So I have a lovely table here with years and percent of total music sales revenue from streaming. I don't want to type in these big numbers because that's going to get awkward, I think, on my graph. So I think what I'm going to do, because we are going to use graphing technology, you are going to use Desmos. And I think what we're going to do, I think it would be best if we use this as 0, 1, 2, 3, 4, 5. I think that would be easiest to use when you put it in your table. So instead of 2010, just use 0. Instead of 2011, just use 1, 2, 3, 4, 5. So go ahead and go back to Desmos and do exactly what we did before. Put in the table. Use that little y sub 1 is approximately m times x sub 1 plus b, and find your regression line. So go ahead, hit pause to work this out on Desmos, hit play when you're ready to check your work. All right. We did skip several pages to get here, but that's okay. I'm going to come back to Desmos. And I'm going to change this up. I'm doing a new graph. So we said that we had 0, 7. So in 2010, we said 2011 would be 1, and that was 9% of people streaming. We said 2012 would be 2, which means there's 15% of US people are streaming music. 2013, so that'll be 3. And then I've got 21% of people streaming music. 2014 will be 4, and we've got 27% of people streaming music. And we said 2015 would be 5, and I've got 34% of people streaming music. Oh, and look, my graph is way changed. Notice this changed along with it. I didn't have to retype it. It was already there. That's so nice. I'm going to go ahead and I'm going to zoom in a little bit, though, because it looks like my graph has gotten a little bit off. So I'm going to just kind of zoom in a little bit here. Make sure, I'm going to move myself out of the way. No. Make sure I can see it just a little bit better. There we go. That's better. Adjust that too so you can still see me. Hi. And here we have our lovely line of regression. Again, you can see our slope is here. So here's my line of best fit or my line of regression. So here's my slope. Here is my y-intercept. Again, I think I'm going to round it to 3 digits behind the decimal just to make this a little easier to deal with. So let me come back over and I'm going to write this down. And I made some notes here as well. I said, okay, X is the number of years since 2010. So I did make a note of that. And actually, I'm going to, you know what, just to make this easier, let's go ahead and round to 1 digit behind the decimal. So if I do that, that means my slope is going to be about 5.6-ish. Yeah. And if I do that for my y-intercept, it looks like it'll be about 4.9. So I'm going to go ahead and round those. So y equals 5.6x plus 4.9. X being the number of years since 2010 and y being the percent of revenue from streaming. Now, if there's a linear association between the independent and dependent variables of a data set, you can totally use a linear regression to make predictions, right? We did that earlier. So use a linear regression to make predictions within a data set. When we found that 85 degrees, it's called an interpolation. All right. So when we're estimating within our data set, it's an interpolation. So I would like you to use your equation to predict the percent of streaming revenues in 2013. I know we had a point for 2013, but I want you to use the linear regression equation that you just wrote to predict the value percent in 2013. So go ahead, hit pause to do the work, hit play when you're ready to check it. So I said, all right, great, x equals 3. That's wonderful, because 2013, that's 3 years since 2010. So I'm going to say x equals 3. I'm going to go ahead and plug it into my equation. So instead of 5.6x, I'm going to say that's 5.6 times 3. I used my lovely calculator to multiply it out and get 16.8. And if I add that to 4.9, I got 21.7. Now, when I go back, so according to our line of regression, our line of best fit, 21.7% of people should have been streaming. That should have been the percent of streaming revenues in 2013. But if you look at the table, it said 21%. So the prediction is a little higher than what the actual sales were. No big. To make predictions for values of X that are outside of the data set is called extrapolation. Okay? So we're going to do an extrapolation. Again, I want you to use the equation you just made to predict the percent of streaming net revenues for 2040. Can you go ahead and hit pause, work that out, and then hit play when you're ready to check your work? Now, if it's 2040, we said that our X was the number of years since 2010. Well, 2040 is 30 years down the road, right? From 2010. So I'm going to say that X equals 30. I'm going to plug it into my equation, my lovely equation from earlier. So 5.6 times 30, which gives me 168. And if I add 4.9, I get 172.9%. Wait a minute. 172.9% of our streaming revenue, that feels odd, doesn't it? Which takes us to our last question, number 7. Is this prediction reasonable? No, it's not, right? More than 100% of music revenues from streaming isn't possible, right? That's weird. That's weird. Once you hit 100%, you've hit all of it, right? We can't go over that. I should also point out that a negative percent from streaming isn't possible either. Does that mean people are trying to send it back via streaming? I'm not sure. As always, guys, I hope you found this helpful and I hope you found this useful. If you got questions or concerns, you can email me, come see me during lunch or during office hours. I'm around. Talk to me and I'll see you guys later. Bye.